Thank you, Mark. And hello, everyone. My name is Dmitrii Naumov. I'm a solution architect at Acumatica. And today my session is performance optimization. We do get a lot of support cases about some third-party solutions being slow in Acumatica, about some processes being slow in Acumatica. And today I wanted to just quickly go through the typical issues that we may face, go through the ways to troubleshoot it, and overall talk about performance optimization and how you can approach that. So our agenda for today is just a quick intro. We will talk about performance optimization and the other side of performance optimization, the downsides of the over-optimizing your code. Then we'll take a look at how to detect the bottleneck and what tools you can use to do that. And after that, we will go specifically through some frequently encountered issues and ways to improve the situation. And we'll just conclude with a short summary. Now, let's go ahead and start. First of all, I want to talk about the performance optimization as an equilibrium. One guy, and the guy is Donald Knuth, once said that premature optimization is the root of all evil. And what I think he meant by that is that premature optimization can cause more issues than it actually solves. And let's take a look and talk a little bit about that. So first of all, when you start to optimize something, you always have a trade-off. You can either optimize something to consume less CPU cycles, but at the same time, you achieve that by, for instance, caching some data in between in order to not recalculate it over and over again. So what's the trade-off here? The trade-off here is that you are going to consume more memory. And well, if you don't really know what types of loads your application is going to work with, if you don't know what the bottleneck is, you may end up making things worse. For instance, if the memory that you have available on your environment is the bottleneck and not the CPU, right? So first of all, you need to understand what to optimize. Optimizing something that may not need to be optimized is a bad thing. And not only because it is a trade-off in performance in other places, but also because it's a trade-off in maintainability of your code. So let's take a look why that could be. I think many of you would agree that the most optimal way to have your software is to write it in assembler, right? That way you control all the memory allocated, you control almost all the CPU cycles. So like you have full control. But I think everyone would agree that that makes your code more obscure, right? So here I have a little picture of a hello world application written in assembler, right? So if you compare that with C# version of that, well, probably it consumes less memory and it loads like less libraries in memory and stuff like that. And it probably works faster. But it's hard to understand what that code does. It's hard to troubleshoot it, right? So that's one thing that can happen when you introduce some code just to optimize performance. You can end up with obscure code. Then let's say you are going to improve your performance by introducing some caching, right? That's a frequent thing to do. Introduce some caches and not request data and recalculate data every time. However, I think it's a common knowledge that invalidating caches is one of the hardest things things in programming. You are almost never sure what is the exact moment you need to invalidate the cache and reread the data, right? You need to track the changes somehow and make sure you do not have the old version of the data, so that it produces another issue. It's hard to catch bugs, right? When you optimize something, sometimes you end up with obscure code, and sometimes you end up with some bugs that are hard to troubleshoot. And finally, one other example that I have here is leaking abstraction layers. What I mean by that is, well, let's take the same example with caching. Let's say you need to invalidate the cache and reread the data, and you need to trigger that from the UI. Now, what happens is that you need to trigger some very low-level event related to the caching mechanism from the UI layer of your software, and that breaks the abstraction, right? You end up with tightly coupled code that is harder to maintain later. So the idea here is that performance optimization is an equilibrium. You need to take into consideration the code maintainability. You need to take into consideration the performance of your application. And you also need to understand the business requirements in order to sometimes even suggest a solution that changes the business requirements a little bit, but is better for performance, right? So the developer is kind of that man on the picture here. So in order to optimize your application in the right way, you need to know your enemy. You need to understand what exactly is being slow and what exactly you need to optimize. And to understand that, we can categorize different sources of the slowness of application. So, for instance, we can categorize it using those three rectangles. It can be slowness, and if we are talking specifically about Acumatica, generally what we see is that first, it can be a database slowness, right? You have some SQL queries that are executed slowly on SQL server side. Second second category that we can have here is application slowness. So that's application server slowness, the server that runs Acumatica application. And the third category that I have here is wrong expectations. And that is actually also frequent reason for the slowness. For instance, if user doesn't expect the process to take a lot of time, and you as a developer can also help with that, for instance, by designing the proper user interface. As an example here, if you have application that performs some heavy process, it will be much easier for the user to look at the nice loading indicator rather than to look at the frozen screen while the process happens, right? So setting the right expectations for the business owners when you are designing the process and for the end users when they are working with the product is also an important part of the performance optimization in a sense. Now, let's talk about, well, slowness of Acumatica applications specifically. And let's categorize it a little bit more. Here I have 4 quadrants, and we can categorize our issue in one of those quadrants. So here we have, as a columns, we have database slowness and application slowness, the same as we had before. And we also introduce additional layer. We have data read slowness and data processing slowness. So yeah, usually it is a good thing to distinguish between whether it's just retrieving data and displaying it to the user being slow, or whether it's some process that does something with the data being slow. Now, that gives us a good idea where to look for when we try to fix the performance issue, but that's not enough. Let's categorize it even more. Okay, so now that picture categorizes the slowness into more categories, more precise categories, and it looks a little bit like that, right? So let's try to simplify it, and let's try to just take steps and look at the ways you can detect the issue, and look at the ways you can understand what causes the issues. So here are the 5 steps that I think are good for dealing with performance issues that are reported by the user or that you see yourself. Now, the first step here is understanding the expectations. So you need to understand how long that process is going to take, like ideally. You need to understand that, for instance, recalculation of balances for all customer accounts is not a fast process, and you cannot expect it to take 1 second on a 50 gigabytes database, right? You should know that, well, anyways, it is going to take maybe dozens of minutes, maybe hours. And if you do not understand exactly what you are looking for, what performance you are targeting to, you cannot really troubleshoot it because you will not understand what the bottleneck is. So the first step is to understand the expectation from the process. The second step is to use one of the tools that we provide or that someone else provides to distinguish between those categories of slownesses, right? So you can understand whether it's application slowness, whether it's database slowness, etc. Then you can use additional tools to detect what exactly causes the bottleneck. Then you can fix that bottleneck, and that you can retest. So the step 5 is also important because, first of all, there may be more than one bottlenecks in your application, and well, you may detect one and fix it, but then there may be another one that becomes visible only after you fix the first one. And second, it helps you to understand whether you have actually fixed the bottleneck or not, and to compare your test results with your expectations. Now, that is all good, but let's get more practical, and let's take a look at a demo that I have here. So, first of all, one thing that we are going to look at is Acumatica instance, and we are going to look at request profiler, which is one of the features that Ruchika has talked about in her presentation, but I want to dig a little bit deeper. Okay, here we have a screen, and let's say, well, I'm clicking that checkbox. Well, I think the session actually expired, so I need to reload it anyways. Okay, so here I have my screen, and I think it works slow. It actually does not, but let's pretend. What I want to do in that case, I want to use my request profiler to understand what takes time, whether that's SQL query or whether that's application server that is slow. So what I'm going to do, I'm going to use request profiler. I'm going to enable the logging here. So here are the checkboxes that you want to enable. So you need to log requests, you need to log SQLs. Also note that when you enable that, it may slow down your entire application. So anyways, we have enabled that. We have cleared the log, so other things do not go in the way. And now we, let's say, select our customer. Actually, let's clear the log once again. Takes some time for some reason. Okay, and let's click that checkbox. So let's say we consider that being slow. After clicking the checkbox, we want the list to appear faster. So let's refresh our results. Here we have that action. And here, the important thing is those two columns. So SQL time, that's the time that it took for the system to retrieve the data from SQL. It's summarized. So if there are more than one SQL requests, the time is summary of those. And then it is a CPU time. So the time that it took for the processor to process the data on the application server side. So let's say that SQL time is a little bit too high, and we want to dig deeper into that. So there are two general things that can go wrong with SQL time. And in order to dig deeper, let's click that View SQL button. So here, I have a list of the requests that are being executed when I click that checkbox. And you can see there are multiple pages of the requests, right? So quite a few SQL requests that are being triggered by that action. First of all, we can look at a single SQL query that is slow. So the easiest way to do that is actually to take this SQL time column and sort descending. And we will get the heaviest SQL query, which is in that case, select from node, node doc, AR register, AR invoice, AR payment, etc. tables. So here is the tables. Here is the row count. So we see that that request took 14 seconds. And now we see that it took 52 milliseconds to execute that request to get the data from the SQL server. We can dig deeper, and we can double click on that request, and we can see the actual SQL request that has been executed. You can see it is quite complex, right? And we will talk about that complexity a little bit later. But for now, the important thing is that we can just take it from here, right? The other thing that is important is that there is a stack trace. So we can understand exactly where that request comes from. So for instance, in that case, it's in pigs.objects.ar, .ar document enq.select details. So we can navigate to that code. And as my colleagues showed you yesterday, you can actually open the source code of Acumatica, and you can see that exact place, and you can understand what's going on there. So yeah, let's say that request is taking more time on SQL that we would expect. One thing that we can do, and let's do that right now, we can copy that request. We can open our SQL Management Studio. I actually have it copied already here. And we can, well, first of all, we can execute it on the SQL server to compare the result. It should be the same. Well, I have a really fast query here to not waste anyone's time. But yeah, you can see that, well, that request executes for some time, for instance. Now, what else you can do with that request is that you can see the actual execution plan. So that is how the SQL server actually filters and queries the data. In order to do that, you can use one of those two buttons. You can use include actual execution plan, and you can run that request. What it gives you the execution plan. So here in the execution plan, you can understand what part of your request actually takes time. So for instance, we can see that that part takes 93% of all our time, and It even shows that, well, adding that index to the table may help to improve our query performance. So that is a very useful tool. If you see some request is not optimal, it executes for a long time, you can understand what specific part of the request is the issue. And from there, you can either change the request so it takes less time, or you can add some indexes to the database and improve the speed of that request that way. However, please remember, optimization of performance is always an equilibrium. So by adding some indexes on a table, you improve the speed of requesting the data, but at the same time, you decrease the speed of write operation. So if you add some index, it does improve this one, this request, but the insert or update or delete requests to SQL for the same table will take longer. So you should always consider that and not to overload the tables with different indexes. Okay, so I think we are done with that. By the way, with MySQL, you also have the tool. It's called Explain in MySQL. You can do something like that. Just demonstrate for those who use MySQL. So you use explain keyword to run the request, and you will get, well, not visual result, but you will get it in form of a table. Okay, so let's get back to our request profiler. Let's say we found out that there is no single heavy request here. So all the requests are kind of, well, normal. But the SQL time here, that we see here, is still more than we expect. So that may be because there are just too many SQL requests being executed from that action, right? Maybe there is no single request that is bad, but it's just too many of them. So what we can do here is we can go to the SQL tab in the request profiler, and that SQL tab allows us to look at summarized, aggregated statistics of SQL queries. So here you can see the number of executions of each request and total time that it took. That is very useful. If you have a lot of repetitive requests, you can see that, well, for instance, this one, if it repeats 20 times, it will indeed be a bad thing, right? And you will see here 20, you will see here, well, total time, which would be something like 500 milliseconds, right? And you will blame that, you will be able to blame that request for the slowness. And you will be able to look where that request is generated and try to improve that specific request, or even avoid that. Maybe it's not even needed. Okay, so now we walked through two possible reasons of SQL slowness. Now let's take a look how to troubleshoot the server CPU time a little bit more. So for instance, we think that server CPU time is higher than we expect. Now, what we can do with that? First of all, we can even use the same request profiler to understand more or less precisely where that time goes. So let's again click that View SQL, and let's now sort it, well, using the start time. So basically, that's when the request has started. And here we can see that, for instance, between those two company requests, we have approximately 40 milliseconds, or if I can count, I think it's 35. Anyways, so we have 35 milliseconds lost between those two company requests. And we see that the company request itself, it took like less than 1 millisecond, and this one too, right? So that time between those two went somewhere. So what we can do in that case, or even like here, right? Even better example. So what we can do in that case, we can open again that SQL text, and we can search for the stack trace. So we can locate the place in the code where it has been executed. So for instance, here, we can locate the next place where the next SQL query has been executed. And we can, by that, we can understand that between those two, some time has been spent. Probably it's wait time or CPU time, right? Because SQL time here is not high. And we can look between those two places in the code and understand where the time went. So that's like immediate thing that you can do from here. However, that's not very convenient. If those things are executed from different places in the code and not from the same method, you will not be able to understand it very well. So let's take a look at another thing that you can do. Let's go back to our customer details screen. Let's unclick that thingy again. So now, starting from Acumatica 22R1, we also have, as a part of request profiler, it's not fully integrated yet, but still. So you can click tools, you can click profiler, you can start logging from here. Now what you can do, you can go to your browser developer tools menu. You can click the developer tools, and then let me do that click. So after I've done that click, I can see my request here, and I can see that server timing window. So that's a new thing. It wasn't there before. So the server timing, it is actually like kind of a part of request profiler. So it also tells you how much CPU you spent, how much SQL, what's the wait time, and it categorizes it the time in a little bit more categories. So you can see here, for instance, we have very useful events categories. So like field defaulting, field selecting, row selected. So you can see that for that action, the cache attached events, so those events that are executed from the attributes, they took 21 milliseconds, right? For field selecting in the graph, it took 15 milliseconds. If you see some big spikes here, so for instance, in field selecting, you can see that there is a big spike. You can immediately understand that, well, you probably need to go into that graph and look for the suspicious field selecting events and go from there, right? So that's another tool that you can use to further dig deep into the issue and understand the root cause of that. And the third tool that I'm going to show is actually a third-party tool. It's not free. I'm not sure if there are like similar tools, but yeah, I'm just going to demonstrate that because that's my favorite. So it's a JetBrains.trace profiler. So what you can do, you can attach to the process. Here it's W3WP exe, so the process of IIS. You can execute some action on the screen, and you will get report. So I'm going to save some time by not doing that live, but I'm just going to show you the report. So in the report, you can see all the threads that are being executed by that process, and you can see what actually it was doing, right? So we see that well, 89% it was just waiting, but let's dig deeper into those 10%. And we see that, well, 1% is on preload. We can dig deeper and see what it actually consists of. We can see the get callback result takes about 5% of our time. Perform select. We can find all those like events if we dig deep enough. I think there will be field selecting somewhere. Maybe I've already missed. Anyways, so here it actually shows you kind of a stack trace, right? So where that thing came from in the code. And you can see nice aggregations by the type of code that has been executed. So that allows you to troubleshoot and understand what slows down your application. Okay, so that was my demo. And now let's just talk about some best practices and some common sources of data slowness. Right, so first of all, we are going to talk about slowness of reading data. And let's start with data view delegates. Nayan mentioned yesterday that in Acumatica, you can intervene the process of data selection from database, and you can have your own data view delegate that executes kind of any code that you want to prepare the data for viewing in the application, right? And that is great. However, you should be careful with those data view delegates. And let's try to understand why. First of all, here we have an example of a screen, right? And that screen displays some records. And what you can do as a user with that screen is that, first of all, you can look at one page of the results. You can navigate to a different page, right? So we can see that there are a lot of records, but we only see, well, 21 simultaneously. We can have filtering conditions to narrow down our selection. And we can see sorting, right? So we can sort the result. Why is that important? It is important because Acumatica has a built-in optimization that when you select data from the database directly, right, with using Bql, using a PIX view, it will try to apply all those things to the SQL select directly, right? So for instance, if we are selecting records, we are only going to see 21 records here. So what Acumatica will do, it will understand that, and it will add top 21 to your SQL request to not select too many data records. What it will also do, it will take your filters that you configured here, and it will add it to your where conditions. And another thing that it will do, it will use your sorting, and it will try to also apply it on the SQL server level, which allows you to retrieve less data from SQL side and thus display it on the screen faster. Now, you can break this. If you have a data view select delegate, and inside the data view, you have another select, that select that you have inside, it doesn't know that you only need 21 records, for instance, right? Or it doesn't know that you have applied an ordering on the UI. So how to make it understand that you are only going to select one page of the records? So the answer is easy. You need to use that select with view context. So that select with view context, what it does, it tries to take the things from UI, the filters, the ordering, the pagination, and apply it to your select. Another additional step that you need to do is that you need to, in your delegate result, you need to indicate that you have, as a developer, that you have already taken care of those things, like of filtering, of sorting, of pagination, and that you are only going to return already prepared results, and the view doesn't need to do it. So you use those is the result filtered, is the result truncated, is the result sorted properties to indicate that, well, the result is ready, just take it and use it as is. Otherwise, the view doesn't know that you've already done that, and it will try to refilter, resort, and truncate the data, which will cause additional processing time. So if you have some grouping here implemented in the code, if you have some complex logic that adds new records to the dataset or removes the records from the dataset, you should not use that select with view context, because it will cause issues. You can only use that if you know that the amount of records you select is the same that you are going to display on the screen. So for instance, in that case, if you are fine with selecting 21 records from that view and displaying them on the screen, yeah, you can use that. If you can select 21 records from here, you can get rid of some records in the code because you don't like them for some reason, then you are going to return less results than are actually should be shown on the page. That may cause different issues with Acumatica not understanding how your pages work and messing up the results. So you should be careful with data view select delegates. You should use that practice when it's applicable. When it's not, you can think of some other ways that may help you to improve the performance of data selection. Okay, so we've talked about data views and how they can impact the SQL query execution time. Now let's talk about the other things that can happen. Implicit joins and subselects that you do not expect to be there, right? We talked about the query being more complex than we would expect. If we go back to our SQL Server Management Studio, we see that the query here is rather complex, right? We have some subselects from node table, we have some whatever case thingy here, we have some joins. And let me tell you, the developer has not written the request like that. The request in code looks much simpler. So let's take an example from my slide. So here you have some Bql example. It's just select from AR invoice, inner join customer on those conditions where that fin charge date is less equal than current date, whatever, right? And you can think, well, yeah, I can pretty much guess what the SQL would look like. Well, that is in fact wrong. Acumatica and Acumatica Bql is a very complex thing that introduces a lot more things to the actual SQL while generating it. So let's take an example from here. When we select from AR invoice, that is actually not a simple table, but AR invoice in Acumatica is a data access class that is derived from another data access class. So in fact, the result here is combined of two tables in SQL. So what it is going to do, it is going to generate some kind of subselect here. So in fact, it will be something like select from AR invoice, inner join AR register. Now, okay, let's take another example, the customer. Again, the same story. What we see in SQL is select from customer, inner join B account. There will be join conditions. And we will also see inner join FSX customer, which is an extension of the data access class. So if you have a lot of customizations on your system, they may affect your queries even in places where you don't expect them to affect your queries, right? So here, that FSX customer is an extension that is used for field services, right? It will still be joined to our select, even though we have nothing to do with the field services module, and so on. Now, we can talk about that last fin charge date field. You can say, well, what can go wrong with that? A lot of things. That field is, in fact, a special field that has a special attribute on it that will generate a subselect. So the select would look something like that. Select max fin charge date from AR fin charge run table where blah, 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 group by blah, blah, blah. So that is a complex select with grouping that will be introduced inside your SQL query. And another thing, things can happen to that query. So in fact, having a simple Bql doesn't guarantee that you have a simple SQL as a result. So first of all, let's see how we can fight that complexity a little bit and improve the performance of our query, right? So for instance, if here for the customer, we don't really need to join B account because we know we only need the fields that we are going to select directly from the customer table. And we are not going to use the fields that we are going to select from the account table anyways. So let's get rid of that, right? Right. In order to do that, we can use inner join single table, special join type in Bql that removes that additional join, right? So here you see the example, we use inner join single table, and instead of select from customer inner join B account, we get select from AR register inner join customer without the B account. So that may allow us to save some time on query execution by removing the joins that we don't actually need. Of course, if we want to use the fields that are from both tables, we cannot use that technique. So another thing that we saw in the query is that fin charge date, right? That generates subselect. So let's see what attributes we should be careful with and what attributes can add additional complexity to our SQL queries. So those are the field attributes, and there are more, but those are the most popular ones. So peak selector attribute. If a peak selector attribute has a description field, has a substitute key, in fact, what it can do when you execute a query, it can generate additional selects, it can generate subselects to retrieve the values of those additional fields that it needs to take from the source table. We have PXDB scalar attribute. Using the PXDB scalar attribute, you can define the subselect that provides the value for the field. It is very useful in some cases, but if you do not expect it to be there, you can end up having very heavy SQL query that you do not know why it takes so much time. Peaks node attribute. So peaks node attribute is on every or almost every data access class in Acumatica. Well, to select the node text, it will generate additional query as we have seen here, right? We can even find it. Here it is. So yes, those attributes will increase complexity of your SQL query. Thus, it may end up being very slow, and you may need to try to remove those attributes. And a tip here, if you don't need some attributes in some particular graph, you can use cache attached event, and you can remove some of the attributes from the fields to make it more light and to make it work faster. Now, there are also data access class attributes that you should be aware of. There is a peaks projection attribute that allows you to generate a subselect for a table. So if you put it on a data access class, instead of just selecting from the table, the data access class selection will generate a subselect in a way that you have defined in that peaks projection. There is a peaks table attribute. So if you see a peaks table attribute on a derived data access class or cache extension, it will generate those joins when you select data from the main table. Okay, so those are the things that you should be aware of, and sometimes you need to remove them in order to improve the performance of your application. So now let's talk about just reading huge amounts of data. Let's say, yes, you have removed all the unnecessary joins. Yes, you have removed all the heavy attributes, but still just amount of fields that you are selecting from the database, amount of data that you are selecting is just very, very big. And well, that is the picture, or kind of a picture that we saw previously. If you see that that field selecting is taking the most time, it means that actually, well, it may mean two things. It may mean that there is still some heavy attribute that has some heavy logic and field selecting, but even just having a lot of fields in your data access class, and each field having its own PXDB field attribute, something like PXDB int, PXDB string, whatever, it may cause that field selecting to grow, and grow. And if you do indeed need to select a lot of rows, maybe you need to restrict amount of fields that you are selecting from those rows from the database. So let's take a look at how we can do that. So first, we can use LINQ to Bql. Second, we can use pigs field scope. And third, we can use light versions of data access classes. And let's take a look at all those things. As Nayan mentioned yesterday, in Acumatica, starting from, I think, 2018 R1, maybe R2, I don't remember. Anyways, in all modern versions, we have LINQ to Bql translation built in the system. So for instance, if you use pig select, AR register select, and you add a where condition, what will happen is that that where condition will be recognized, and even more complex where condition will be recognized, and it will be translated directly to SQL and applied to the SQL query. So again, the same thing as we saw with the UI filters, we try in Acumatica to propagate all possible conditions from code, from UI, directly to the SQL server to reduce amount of data that we are selecting as the first step, right? We do not want to filter the data later after retrieving it. So we want to filter it like right where we take it from. So for instance, another example here is if you add first to default to your select, again, Acumatica will recognize that. It will add top 1 to your select, and it will return the 1 record. It will not even try to select more. And if we get back to our current topic, how to restrict amount of fields that you're selecting from some table, you can use the same thing. If you, for instance, use that pig select and you add select that lambda here, so underscore dot reference number, it will indeed propagate that to your SQL. It will not add other fields. It will only select that reference number because it knows that you are only going to work with that reference number field. So if you can predict how many fields you want to work with. You can even do it like that. You can add linQ statement and it will be propagated. If it's not too complex, it will be propagated to SQL level. That will result in other fields in the data access being in the data access class being nulls, and the application will not spend time on processing that. Another thing that we have, it is more specific to restriction of the fields. It is a Px field scope. So you can use field scope and you can define which fields you need, and you can select from a view using that field scope, and that select will only generate the query for the fields that you define here and for key fields as well. All other fields of the data access class will be excluded, and again, the application will not spend time on processing those fields. And yeah, let me remind you that picture that we had before. Remember that performance optimization has a trade-off, right? And in that case, with the third practice that I'm going to demonstrate you here, I think it has the heaviest maintenance cost. So the third practice that I want to demonstrate is using light versions of data access classes. So let's imagine we have a customer data access class that is derived from Backend data access class, and it has, let's say, 238 fields. I just made it up. I don't know how many fields there are in the customer table, but that seems realistic. Now, if we are going to select that, first of all the attributes on all those fields will be triggered. We will also have the join to B account, as we know, etc. We can introduce another customer class, another data access class, customer. We can put it in a different namespace, for instance, Px objects AR Lite. We can remove the B account from here. We can remove the fields that we don't need, and we can left only 3 fields. We can remove the attributes that we don't like, and we can work with that type of data access class. Why that is heavy on the maintenance side is because you now always need to remember that you have that specific customer class, data access class, and then you need to take care of it every time you need to change something. Like you may want to add some field here, or the base class changes and you need to remember to change this class. So yeah, there is a trade-off, but that is a efficient way to reduce the amount of fields that you are going to work with. Okay, so I think it takes a little bit more time than I expected. Mark, can we go a little bit over time? Mark? Okay. I think let's just continue and we'll see. So now let's talk about optimization of data processing. We have talked about how to optimize retrieval of the data. Now, what if you need to do something with that data, process it somehow, and that part is being slow? First of all, let's talk about some processing screens in the Acumatica, for instance. So that is a kind of generic example of processing delegate. So the method that performs some processing. So it iterates through list of documents, it creates graph, it creates a new document in that graph, assigns some fields, inserts the document, saves the result, and it repeats that for every document in that list that we receive. So can you spot what's wrong here? Can you spot what's going to cause us some performance issues? Let me tell you. that thing, pxgraph create instance, it will cause some performance issues for us because we do it for every document in the list. We repeat it many, many times. And that is actually a very heavy operation. So when you instantiate a graph, what it does, it instantiates all the caches, it finds all the data access class extensions, it finds all the graph extensions, it checks whether those are active or not, whether you have access to that or not, and stuff like that. It's a lot of things that are happening. And of course, those are taking time. Now, how to fight that? Well, the simple way to improve that code is to just put that outside of the loop. Now, we do not want our documents to have some effect on each other. We want to keep them separate. So because of that, in every processing step, in every step of that loop, in every iteration, we are going to clear our graph before we do some things with that. So we create graph once, we have all that heavy stuff once in the beginning, and then in the loop we are only clearing the graph caches each time we need to process a new row in that list. And that is how we save time. Okay, so we are using the graph now. Let's say here's another code example. And here, compared to the previous one, what I have added is that for each loop, that inserts document lines here. What can go wrong with that one? Actually, if you have a lot of document lines, so let's say you have dozens of thousands of lines, what can go wrong is that the graph caches may be filled with those lines, so it consumes a lot of memory. It takes a lot of time to iterate through all those cached documents if something needs to be recalculated. So you may end up consuming a lot more memory and a lot more time that you would expect. How to fight that? Well, in fact, you can save it, well, not on each step, but let's say for every 1,000 lines, you can save that document details. That way, you will allow the graph to push the data chunks to the SQL server side and not to keep those records in the application server memory, right? So that may help to increase the performance of that processing. Okay, so let's now talk about some processes that are just naturally heavy and slow. And example of that heavy process may be data recalculation. So let's say you want to recalculate balance on your bank account. And to properly do that, what you need to do, you need to start from the beginning. You need to take all the transactions that you have done, and you need to apply those adjustments to your initial balance. That is probably 0. Then you add all the positive ones, you subtract all the negative ones, you end up with the ending account balance. Well, no one really does that, right? So when you open your bank app on your phone, it doesn't go through your account history from the beginning of time. It already have that account balance pre-aggregated and saved in some variable, in some like database. That is very trivial example. We all know that it is pre-aggregated, but it is here to demonstrate that there are some processes that may need the same approach. So for instance, instead of calculating the result when the user wants to see it, you can push that calculation to the moment when the change is actually happening. Or you can push the recalculation for to the nightly scheduled task, right? So like every night you can recalculate the account balances, then user opens their general ledger in the morning and they see the recalculated balances, right? So it is just to demonstrate that for some processes, yes, it takes time. So you can just either distribute it over time, or you can calculate it some other time. And that way you will improve the customer, the end user experience, while, well, the process will still take time, right? So another example, data recalculation that is actually complex. Let's say discounts recalculation. Imagine you have an application that have very heavy discount logic. It gives discounts when you have some items of the same time in the same quantity, but then if you change the quantity, a different discount applies, etc. So now when a user starts to add lines in your, for instance, sales order, user adds one line, and each time after adding that line, the discount logic triggers and recalculates all the rules, checks all the lines. So the more lines you have, the more times it will go through all the lines and it will recalculate discounts every time. So it ends up being quadratic complexity, and on a big amounts of lines, it will slow down the system significantly. So what can you do here? You can just push that process to the end of the user interaction with the system, right? So you can let the person enter all the lines in the document and have a button that they need to click to recalculate discounts in the end. It changes the user experience, but it makes the UI itself more responsive in cases when they have a lot of lines, right? So again, I want to bring up that picture. You trade off some, well, UI behavior, or maybe having the data up to date up to a second in, and on the other hand, you have performance, right? So maybe for some data, you don't really need to have data very up to date, right? You don't care about seconds, right? You are fine with the data that is 1 day old. So in that case, you can just push your process back to nightly schedule and let it recalculate the data once a day. And your users will not see the delays, and they will be happy with, well, a little bit aged results. Okay, so the last topic that I have is saving data to the database. So what can go wrong? What can go wrong with saving data to the database? Let's say if you have a big chunk of data that you want to save, you usually have it in a transaction scope. So for all the financial applications, it's important to keep the data consistent, right? You do not want to take some money from one account and not to put it on another account, right? You need the data to always be consistent, and because of that, you use transaction scope. And I hope everyone knows about the transaction scope and what it is. If you don't, you can Google it real quick. It is a must-know thing for ERP development. Now, let's say we have a big chunk of data that we want to save at once in one transaction scope. What may happen is that that transaction scope may just consume all the available memory on your SQL server, and your SQL server is going to be very slow. What else can happen is that your transaction scope commit process will last very long, and during that time, you just lock all the tables, all the records that you are saving, and you are preventing all other processes from working with them during that time, right? So you can slow down another process, a parallel process. So What you can do with that, you can actually just cut the transaction scope into pieces. But again, you need to remember, you do not sacrifice data consistency where it's critical to get more performance. If it's acceptable, for instance, if the data that you are going to save is, I don't know, some logs of events that are frequent and you don't really care if you cached all of them or not, yeah, okay, you can just cut that transaction scope into pieces and you can save data chunk by chunk. If it's a financial data, you do not do that. You just keep it as a priority to have data consistency, and you have to sacrifice the performance. So to summarize what we talked about, first of all, do not optimize with what you don't need to optimize, because it always comes with a price. Now, when you need to optimize something, you need to identify the exact area, and you need to understand what exactly is the bottleneck. And you can use some tools that we have demonstrated yesterday and today in order to do that. And finally, when you understand what causes the slowness, you need to use some best practices that I have demonstrated today to improve the performance. Okay, that was it for me. Thank you everyone for listening,